Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science
Put that
Guy.
out there. Now we're going to take this to the spec. So let's clean both sides of this before we start anything. Then we're going to put this in the spectrophotometer here. Close the lid. Then we're going to go here and we're going to hit 0. We loaded the blank and now we're going to hit OK. Alright, now that it's zeroed out, so we're going to take this blank out now, pull this here, and set that down. Let's get our sample that we're trying to measure here. Going to clean the sides again. Put it in like that. Close the lid. Going to go over here now. Going to hit start. Just going to call it sample 3. Let it read. And then we'll measure this absorption rate that's written up here.
I think it's time to blow this scene. Get everybody in the stuff together. Okay, 3, 2, 1, let's jam.
I forgot what I was gonna say next. Actually, I'll start from this side. Okay, just tell me where you're going. So today we're talking about the Beer-Lambert law, and it is represented by this equation here, which shows the relationship between absorbance and the concentration of a solute in a solution. So A stands for the absorbance, which is measured by the spectrophotometer. The molar absorptivity is a constant that should be given. The C is the concentration of solution in moles to liters. The L stands for the path length, which is the width of the cuvette. In this case, it was 1 centimeter. And another thing to note that's important is the absorbance and the concentration are directly correlated. If the absorbance goes up, the concentration is going to go up. Or if you were to flip that around, if you have your concentration going up, that means the absorbance is also going to go up. So it's really important when you're doing these calculations, before you do anything, to make sure that you zero the machine. The reason for this being is that if you don't zero the machine, since your sample has water in it, it's not going to be able to distinguish from the water in the actual sample. When you have a scale, if you don't zero the scale first, it's not going to be able to determine what weight you're actually putting on the scale because it has an inaccurate value already applied to it. So as we talked about before, the Beer-Lambert law gives you some exact values and ways to calculate those values. Here, this is what we call the qualitative side of things. It's more of a visual representation instead of like an actual number value. So here you can see that we have our absorbances on the graph here. And up here is our peak or the lambda max, which we observed when we put our samples inside of the spectrophotometer. So a question that you may ask is why scan across all different wavelengths? If you don't scan across all the wavelengths, you can get some inaccurate results as you have right here, because it doesn't encapsulate the actual full range of the data. You can't capture all the different absorbance rates of the sample.